Good morning, everybody. Welcome to the first day of the Corona Apocalypse, NTI day number 3. We're going to talk about sampling distributions today. You've got an example problem dealing with students who are doing their homework, which I think is really appropriate given that it's NTI day. How many people are going to do their homework? Well, we'll get into that in just a second, but first I have to tell you about a fellow who went into a pet store to buy some bees. And the pet keeper said, "How many bees do you want?" He said, "I want a dozen." So the storekeeper started counting out the bees, and he put 13 in the box. And the fellow who was buying the bees said, "Wait a minute, that's one too many." The storekeeper said, "Don't worry about it. The last one's a freebie." Ta-dum-dum. Okay, so here we go. Newspaper article claims that about 60% of the students are doing their homework. Some people are skeptical, and so they design a simple random sample of 100 students to interview to find out what the sample proportion, p hat, this is p hat and it represents the sample proportion, to see if that would be consistent with a claim of about 60% doing their homework. And once they did the one sample, they took that data and they plugged it into Fathom software to simulate 250 more simple random samples of size n from a population with a true population proportion of 0.6. And so all of those 250 dots are represented here on this dot plot of the various different samples that were randomly generated using Fathom software. So the first question is this the sampling distribution of p hat? And the answer is no. It is not the sampling distribution of p hat, because that would require that we take all of the samples of size n equal 100 from the large high school. And we don't know how many that is, but we know that there are a lot of samples of a certain size in a large population. So is this a sampling distribution of p hat? No. But it is a good approximation. And so later on, we will begin to use the data that we've obtained from this simple random sample to approximate the sampling distribution. Okay? So the second question is describe the distribution. Well, this is where we want to do SECS. I think you can tell by looking, the shape is roughly symmetric. Wouldn't say it's bell-shaped, but it's definitely single-peaked and roughly symmetric. The next one is outliers. Well, we haven't done any calculations, so we can't say for sure, but we see some out here on the right tail and the left tail that could possibly be outliers. We'd have to check and make sure. The center appears to be centered at 0.6, which is what we would expect because the population from which these samples were drawn came from a population where the true proportion is 0.6. And the spread, well, we can't really calculate the standard deviation from the data we have, but we can say the range is the difference between, say, 0.73 and, say, 0.47. So we might say the range is equal to 0.73 minus 0.47, and that's equal to whatever that is. Okay, so there's our description of the distribution. Now suppose that 45 out of the 100 students in the actual sample say they did their homework last week. 45 of the 100 in the actual sample. what would we conclude about the newspaper article's claim? Okay, well, what did the newspaper article claim? The newspaper article claimed that the proportion of students who did their homework was 0.6. And if we got a sample that said that only 45 claimed they did their homework, well, 45 is right here. And in 250 samples, we didn't get a single example as low as 0.45. So we could certainly conclude that it is very, very unlikely to get a sample of 0.45 if the true proportion is 0.6. Therefore, we would say we are skeptical of the newspaper's claim that 60% of students did their homework. That 0.6% or 0.6 students, or a ratio of 0.6 of the students did homework. Okay, so hopefully you guys are treating your NTI work a little bit differently. Hopefully that number is a lot higher. Okay, because, let's go back over that one more time. Because we got a sample of 45, or a proportion of 0.45, and in our simulation, none of the 250 simulations gave us a sample that low. That leads us to believe that we are skeptical that the true proportion lies at 0.6. Okay? So the fourth question, I guess, is we want to make a graph of the population distribution given that there are 300 or 3,000 students in the school. Okay, and so our hint is what type of variable are we measuring? Well, we're not measuring a quantitative value. We're asking a question: did you do your homework or not? So this is a categorical question. About the only kind of graph we can make is a bar graph, and so we'll make a graph that looks something like this. And we know that if the true proportion is 0.6 and there are 300,000 students, then the number of students who did their homework would be 0.6 times 3,000, which is 1,800. The number of students who didn't do their homework, therefore, would be 3,000 minus 1,800, or 1,200. So we might make a bar graph that looks like this. Some said yes. Some said no. And the number that said yes is 1,800. And the number that said no is 1,200. Remember, we can't make a histogram because this is not numerical data. It's categorical. The best we can do is a bar graph representing the number of students who said yes versus the number of students who said no. Okay, sketch a possible graph of the distribution of sample data for the simple random sample taken out of size 100 taken by the stat students. In other words, out of all of the possible samples, let's just graph one of them. Well, we don't know what that is, but we can. The question asks us for a possible graph, so we want to come up with something reasonable. Now, your graph might look a little differently, but again, we're going to have a bar graph. It's categorical data still, so we're going to have some group that said yes, some group that said no. How many said yes? You pick. It's a possible graph of the sample data. So looking back at our distribution, though, any reasonable value between 0.5 and, say, 0.7 makes sense. So I'm going to say that in my graph, 0.55% of the students said, or not, a proportion of 0.55 students said yes, and so that means a proportion of 0.45 students said no. Now, your graph can look differently. You could pick 0.6 and 0.4, or 0.63 and 0.47. You can pick anything that makes sense based on the sampling distribution, or the estimated or approximate sampling distribution that we came up with. Because here is the proportion that said yes, and so the proportion, any sample of size n equals 100 coming from the true population distribution could make sense. Okay, well, I hope y'all are having a great day. You'll get some more information. I've got a practice problem for you to do, and you'll see that in your Google Classroom. So y'all have a great rest of the day. Send me messages with any questions you have. Talk to you later.